Hey, what's up everyone? This is Corey Glenn, and I'm going to show in this video today how to make a poor man's metal reinforced hybrid. Many of you may know I do a lot of immediate load implant cases where we have an immediate load restoration made ahead of time, and generally we print these. The downside to printing is that you don't have anything that's super strong reinforcing that, and there's always the potential that you could just crack this thing through and through. And so what I'll show today is how to use just a cheap titanium plate that anyone can obtain off Amazon and build that into this hybrid so that you have a super strong restoration that's going to be very difficult to break. Real quick before we get into that, I was going to let you know I've got my comprehensive guided surgery course coming up on October 13th and 14th of 2023, and that will be up at my farm in Sewanee, Tennessee. So if you're interested, you can go to coreyglenn.org, and that's got the link to the registration page. October is always a beautiful time of year in Tennessee, so hopefully you get to see some good scenery. It'll be a great course. We'll go over everything from A to Z, assuming you know nothing, starting with guided surgery, and get you to where you're proficient with any kind of routine case, and we'll go all the way up to the more basic full arch guides. We'll cover printing, we'll cover some mesh mixer, a lot of prosthetics, a lot of surgical techniques. So it's really a big course, and it is hands-on. You'll actually work through multiple cases on the computer, as well as go home with tutorials about that. So with that said, let's go ahead and jump into this technique. So full disclosure, this is the first time I've ever done this, and I'm just documenting it because I know it works. It's not really a question of that. But I was doing another project, and I happened to get on Amazon, and I was looking for a small piece of titanium plate. And I was amazed at how affordable this was. So you can get on Amazon and find these 2 millimeter thick titanium plates. They're about 100 by 100 millimeters for $10. And that would be enough titanium to reinforce a good 5 to 6 restorations. So we're talking about very minimal cost to this. And what we can do is just trim a shape to fit into that hybrid so that we can have that metal reinforcement. It's obviously titanium, it's super strong. Be honest, I don't even know that you need to go with the full 2 millimeter thickness. I think a 1 millimeter thickness would probably get it and be a little less trouble. Just to give you a big picture of the process, what we're going to do is take our hybrid that we've designed. In my case, it's a stackable hybrid to go on a guide, but it could just be a routine full contour hybrid with no stacking or anything like that. What we're going to do is design and then 3D print a template that we can lay onto that titanium plate to trace out the outline, and then we'll just trim that titanium plate to the correct shape and then print the hybrid with the socket, I guess you'd say, for that plate to go into. All right. And so here's kind of the idea. You can see that I've printed my template, and we'll go over how to make that here in just a moment. But what you want to do is go ahead and trace the template out, and I here use a round burr because pencil's going to rub off pretty quickly. So I just went around this. I had tacked it down to the plate and then just went around with a round burr and traced the outline as well as my pickup holes. And here you can see that that has been cut to shape. Now, this is a very fast technique to do in the software part of it, easier than a lot of others I've shown. The downside is that the cutting of it is by no means easy. And after I had gone through about 25 round burrs just to get about 5 millimeters of my cut going, I thought this is not working. We got to use some real tools. So what I'd suggest if you're going to do this, and this is kind of the only downside in my mind, is you're going to need to use probably an angle grinder to cut the outline, and then you can come back, and I like to use a drill press for making the holes. Again, you're just going to save yourself a lot of effort in spent burrs and all that kind of thing. So might want to have some real tools, and these are not expensive to get. Hopefully you already have them like I already did. So once I had cut that titanium to shape and test fit it into the restoration, I knew it was fitting. I just thought it'd be cool to go ahead and anodize this. And so being titanium, that's one of the advantages over other metals is that we can easily anodize different colors onto it. And since I'm going to be wrapping this in some pink resin, I thought it'd be good to go ahead and make the bar pink so that there's not any metal show through on that. If you don't already have a titanium anodizer, this is actually the unit I have. Now, let me go ahead and throw out the disclaimer that you probably should warn your husband or wife before this bill shows up on the credit card, because when I ordered mine from Painful Pleasures, I got the call. I'd used the Blue Sky Bio credit card, and I got a call from our general manager being like, "Hey, man, what are you spending Blue Sky money on?" So I had to explain that this is a titanium anodizer, but this is used in the piercing and the jewelry supply business. And so I guess if you get a titanium belly button ring, you could have a different color for every day of the week. But it's a super, super easy process. Again, you can see this $250. It's not a big investment. But this will let you anodize titanium, anything you've got, custom abutments, reinforcement bars, all of that stuff, to a whole range of colors, basically every color in the rainbow. So might want to look into this if you don't already have one of them. But I turned the bar pink, and then I went ahead and just cemented it into my restoration that had the socket. I use a dual cure resin cement for that, because if you try to use just printing resin, there's no way that you can cure through that bar to get the interface where it's bonding to this restoration. All that light's getting blocked out. So cement the bar in place using a resin dual cure cement. And then after that's been done, I want to go ahead and fully encase this bar. And so I chose to use Ceramco denture-based resin. This restoration is printed out of Ceramco's Crown and Bridge material, Crown Tech. And so I just chose to use their denture-based resin and went ahead and wrapped that so it's fully encased in resin, and I can get, nice, smooth, polishable contours on it. Following that, I went ahead and just began applying some pink stains. So this is Optiglaze red. So I think I did 2 drops of red and then 4 drops of the clear, just to bring it down where it wasn't so aggressive. But even at that, it took, several coats of this, because you are printing a monolithic restoration. All of this was printed in Crown and Bridge resin, so it's all white. So that bleeds through quite a bit through this thin resin. So you'll put on the staining pretty heavily, and I don't know how easily you can see it, but you might notice I do have cutback on this. So one of the downsides to just applying a stain on a printed restoration is that, in 5 to 6 months, that stain is going to wear off. There's just no way around it. And so what I like to do is have some cutback done on my restoration. You can do that by hand or digitally, but then I can apply the staining, and then I'm going to apply a thicker resin. Again, in this case, I used more of the pink denture-based resin, so I know it's bonding well to this material, and that's giving it some thickness over the top of my staining, but the staining color still comes through nicely because most of those denture-based resins are pretty translucent. All right, so I've gone ahead, I've bonded the bar in, I've applied some red staining, and then here you can see I've just gone ahead and done some gingival festooning, tried to make the pink look somewhat nice, and then polished everything up. Put a surface coat of nano varnish from Dreve. I really like that as a polish on printed restorations, and that was kind of the final result. And again, mine is a stackable restoration, but this could be done on any kind of a printed or even a PMMA resin if you don't have a mill to mill more of a customized titanium framework. And I'll mention too, usually what I'll do is I'll just print this, and that way there's no cutting it to shape or anything like that. Uh, but you do have to pay for the print, and that's going to be a couple $100 usually. And so this is just a cheap alternative. It's really fast in the software to make. The only downside again is the trimming of it, and that's a little bit of a pain in the butt. But once I started using the bigger tools, it was no problem. So let's go ahead now and go into the software and let me show you how I made this. So here you see this restoration. This is how I designed it, and right now this would be if you were just going to print or mill this, but there's no reinforcement of any kind in this. And I know I've shown on many different videos a lot of different ways that you can reinforce this. You can use Trilor, you can use fiberglass, you can use a custom metal framework. There's so many options. Again, this is just adding one more option to the toolkit. And so what I need to do is, I know this plate is 2 millimeters thick, and so I need to create something that will fit inside of this restoration, and we'll have about 2 millimeters of thickness. So what I'm going to do to just start that process is take this, and using Mesh Mixer, I'm going to grab just a primitive shape here. This is a cube, and I'm going to drop it onto this where basically it's going to be oriented pretty flat to the bottom of the surface. and we'll accept that. But now what I'm going to do is go ahead and expand this. We'll make this maybe, 50 millimeters by 50 millimeters. And then you can just scale it manually to whatever distance you need to. And then as far as the thickness, again, my plate is 2 millimeters thick, so I'm going to make the plate be 2 millimeters thick. And now I'm going to move this thing down, and if I need to, get it a bit more flat to the surface, I can do that. I pretty much want this thing as flat to the surface as I can have it. All right, so that looks good. And then I'm going to move it down just a little bit deeper into the restoration. And you could even go deeper than this. In fact, there's some advantages to that in that you'll have a bit more thickness of your material once you wrap it. Because if you leave that wrap resin paper thin, there's a decent chance it could flake off. Okay, so let's just go with that right here. Also need to move this just a little bit this way. All right, so now we've got a 2 millimeter thick titanium. Well, this is not the titanium plate. This is kind of mimicking that, okay? And what I want to do, I'm going to do a Boolean intersection, meaning wherever these two objects touch, it's going to get rid of everything else but that. But before I do that, I do want to keep one of my hybrids just in its original form. And so I've got it duplicated, and now I'm going to go ahead and do the Boolean intersection. Now, before you just jump to that, one thing that is good to know is that if I turn on the wireframe, you can see my hybrid has an incredibly dense mesh of triangles, right? It's very high detail, whereas this has got just these ginormous triangles. It's not very refined. And just again, from experience, I know that whenever you do this, Boolean functions don't seem to work well in Mesh Mixer unless you have similar triangle counts on the objects. So there's a couple of ways I could do that. I could just Control A and go up here to remesh and increase the density of the mesh. But I've also found just an easy and quick way to do this is if you go and just make solid. All right, do you see how that basically kept the exact same shape, but now I have a much denser mesh, and I could further increase that, by increasing the mesh density and sliding this. So we'll accept that. And now this is going to perform much better in that Boolean intersection. All right, so it doesn't really matter which one you click first, but I'm going to control click both of them. When I do that in Mesh Mixer, you'll see Boolean intersection. Go ahead and choose that. And there you see it's finished. I'll go ahead and accept that. And there we have it. So, I could go and manually trim off these things, but let's go back and turn on our original hybrid right now. I don't really want this thing to go all the way out here to the edges. I want to leave that a little bit shy so there's no show through of that. And so I'm not going to just make this the final template. If I was going to, I could just simply cut off some of these little nubs and stuff and we'd be off to the races. But instead, what I'm going to do is I'm going to just choose this face group that was created and then hit invert, which chooses everything else, and I'm going to delete all that other stuff. All right. And you can see basically now this represents just a one-dimensional slice about right through there in the restoration. Okay. Again, I want to leave some thickness of the resin on the facial in particular. So what I'm going to do now is go ahead and using my select tool, I'm going to double click one of the edge triangles. Sometimes it's helpful just to really zoom in here. Double click that. Oops. All right. And now I'm going to increase that selection. Okay, so hold down shift and hit your greater than. All right, your alternative way of doing that is you could go up here under modify and expand the ring. All right, and just repeat that several times. I want to pull this in from the edges a decent amount. And then if there's anywhere that, I'm starting to get a little thin around my holes for the pickup holes and I wanted to maintain some strength, I could go ahead and just erase a little bit right there. And maybe right here as well. And maybe in one more spot right here. Okay. And maybe right there as well. And I'm going to smooth this boundary of my selection. So I'm going to hit O for optimize boundary, B for smooth boundary. And I'm going to also increase the smoothness of that. and now we'll accept it. And then delete it. This is going to be essentially the shape of my my reinforcement. And do you see how now when I've got this on transparent, you can see that it's pulled in away from the edges everywhere. That's really what I'm after, okay? So now we need to make the template. All right, we've got the overall template shape, but we need to turn this into the actual template that's going to represent what we're going to trim the titanium to. Very simple way to do this. All right, so notice this is kind of embedded down inside of that. What I want to do is Control A, so I've selected all of it, and now I'm going to push D. D is extrude. Okay, now remember that this was the back side of the mesh. If I cancel that, this is the back side of the mesh, this is the front side of the mesh. So when I push D to extrude it, it's going to extrude. The positive direction is going to come straight off the face of that. Well, I actually want it to go the other direction. So what I'm going to do is make this -2, and now that would be an exact representation of that 2mm titanium plate. All right, so what I'll do real quick is export this, and I'm just going to call it template for bar. So that's done, and now I just need to build in that same socket into the restoration. Okay, now when you do that, you're going to see that this is not protruding all the way up through the restoration, and thus you would have a lot of hand trimming to do. But since I've already saved that shape, let's go back here now, and I'm going to create a face group out of all of this flat surface. So go to Edit, Generate Face Groups. When you do that function, it's just looking for changes in the contour. So generally, if you've got a big flat shape and then it's got these 90-degree edges, it will turn all that flat surface into a face group, and then everything else will be something else. And that just lets me now quickly choose that top surface, and I'm going to go ahead and hit D again and just extrude this up high enough that it's penetrating all the way through the restoration, okay, because I want to create that socket. All right, so now we could just do a straight up Boolean difference here, but if you do that, you're not going to have any wiggle room or slop space around this. And so what I would suggest you do is go ahead and offset this by just maybe 0.2 to 0.3 millimeters, just to give it a bit of slop space around that. So Control A to select it all, and I'm going to offset, and I'm going to offset it by 0.2 millimeters. And it's going to default to offset by the last distance you used whenever you did this, so I just need to change this number to 0.2 and then let it refigure. Okay, now we'll accept it. And you'll notice that this is still selected. So what this is that's selected is your newly offset surface. The original entire surface is still internal to this. So while it's still selected there, I want to separate this off into its own STL. I'll do that by hitting Y. And you'll see now, there's the original shape, right? And then here is the newly offset space. So okay, so what I want is this newly offset surface, right? That's this one here. And all I've got to do now is subtract that from my original hybrid. So I'm going to choose the hybrid first. Always select the object you're subtracting from, and then Control select this one in your objects browser, the newly offset surface. And this one's going to be a Boolean difference. And then we did have something fail here. So I'll try to just show this, since a lot of times that's the trouble in Mesh Mixer, is not knowing how to address little failures and stuff like this when you get them. And so I'm making a note here. Anytime you have a failure of a Boolean function, you're going to see either some red or blue lines pointing to something. Sometimes they're internal, so you may not see them, but make a note of where that is. Excuse me. And now I'm going to just go ahead and hit accept. It's not going to make it go all the way through, but now I need to look. Now why did that fail? Okay, and this will help if I make all of that hybrid just a different color and make all of this a different color. Okay, so now when I'm looking through here, you see there's just this tiny piece of mesh that is, if I turn on the triangles, you'll see it's just so small here that like in this area, it can't subdivide those triangles. And you can actually see that going on right here. You see this, even though we've got a relatively dense mesh, it's just not working. So that's a pretty easy fix. What I'm going to do, since that's in a non-critical area, is I'm going to use my sculpting tools and go up here and use the shrink smooth tool. And I'm just going to, on the hybrid itself, I'm going to just shrink those areas back where they don't even penetrate through. And even though these over here didn't fail, I'm going to go ahead and do the same on that. Now, in that scenario right there, when I was hitting shrink, it's not shrinking back to my liking. So your other option is use the inflate tool. If you just click, it's going to inflate this, right? But if you hold down shift, it's a deflate tool. So I am just deflating that area. I'm sorry, it's actually control that you hold down. And then I'm going to do the same thing over here. And we'll do that one too. And now let's give it another try. Control select, Boolean difference. And that time it worked with no problems whatsoever. So we'll accept that. And what I'm going to do is just bring back in my original template. You can kind of see how this is all going to fit together. So let's import. All right, make all that a different color. And so now you can see this is the bar inside of that. So if I print that template and then I trace it out on that titanium sheet and then cut it to this exact shape, then it should fit down in here, and you can see it's got a little bit of slop space between it. And then even once I've done that, you'll see that it's still inset by, maybe a millimeter or so on the bottom of this, which is going to let me now fill in and wrap around this bar in another resin. Again, in my case, I use the denture-based resin. That way it's fully encased, it's easy to polish, it's just kind of an easy scenario. So that's basically the process of how I did that. And now you would just do all the steps that I showed as we initially started this video. Again, you just print it, trace it out, cut it to shape using your big tools or 500 round burrs, whatever your preference is. And then you can anodize it and then bond that in. Again, do use a dual cure resin cement to bond in your bar, and then just fully wrap it. And now you're just characterizing it with some gingiva like you would any other kind of a printed or a PMMA restoration. So anyway, I hope you found that helpful. Again, if you're interested in coming to the guided surgery course, that's a great course for beginners in all things digital, frankly, because you'll learn a lot about just CAD and printing in general, and specifically about guided surgery. That will take you from knowing nothing all the way up to being very proficient in any number of cases. The vast majority of cases you'll probably do. So anyway, I hope that you can make it to the course, and look forward to seeing you.